Problem number 6. This is what you're supposed to work on last night. We'll see what you score. The highest score from second hour was an 8. 8 out of 9. A couple of people got 8s. So, consider a differential equation dy over dx equals e to the y times 3x squared. All right. Let y equals f of x be the particular solution to the differential equation passes through 1, 0. So this is going to be an important point to know. It starts out, and I would suggest to you that everybody can do question A. Doesn't mean you're going to get it right, but everybody should feel confident putting forth the effort. It says, write an equation for line tangent to the graph of f at point 1, 0. Use the line tangent to approximate f of 1.2. What is my goal? What am I trying to do? Create a line. So I need slope and what is the point on the line? Here we go. So how do I determine slope? Am I given the original function or am I given the derivative? I'm given the derivative, so how do I find the slope? Plug in x and y. Yeah. So I have e to the 0 times 3 times 1 squared minus 6 times 1. And so I get e to the 0 is 1. 3 times 1 squared. 3 minus is so negative 3. So once again, that should be points that everybody can come up with. Okay? Everybody. Now I'm asked to write an equation for a line tangent. So all I have to do is come up with my equation. I got y minus 0 equal to negative 3 times x minus 1. You can actually leave the answer like that on the AP exam. If you're like, you know what? I don't want to write in slope-intercept form because I'm afraid I'll make a mistake. They would accept that as your equation. Yep. I plugged in 0 for y and 1 for x, and it gave me negative 3. So, as I solve here, I have y is equal to negative 3x plus 3. And now I'm going to use that to approximate f of 1.2. So how do I approximate f of 1.2? Yep, f of 1.2 is approximately equal to negative 3 times 1.2 plus 3, which is negative 3.6 plus 3, or negative 0.6. So, for this scoring, they give you 3 points. They give you 1 point for coming up with the negative 3. They give you 1 point for coming up with the linearization or the line tangent. And they give you 1 point for coming up with the estimation of negative 0.6. We got 3 out of 3 going so far. And of course, you had to try it in order to get the points. Okay, so it doesn't count to write down what I have. So. All right, so we move to B. Only 2 parts to this problem. We move to B. And it says find y equals f of x, which is the particular solution, not the general solution. The general solution would just have C. The particular solution will involve our initial condition, which is 1, 0. Notice how nice they are to let you know that twice. So you understand that they are trying to make a point about what the initial condition is and help you along the way. They're not trying to be misleading. They're really trying to be quite clear with what they're doing. So let's do that. We have to set it up. I have dy over dx is equal to e to the y times, what is it, 3x squared? 3x squared minus 6x. So I must start by the separation of variables. I will gather my x's and my y's, and dx with my x's and dy with my y's. So I have dy over e to the y is equal to 3x squared minus 6x dx. Okay? And so you'll get a point for just doing that. Again, to me, non-negotiable. Everybody can separate the variables. You just have to know that that's what you were supposed to do. How do we get rid of the dx and the dy? Integrate. This integral is easy. What's the antiderivative of 3x squared? X cubed minus plus a constant is equal to Everybody agree that this is the same thing as the integral of e to the negative y dy? What's the antiderivative of e to the y? E to the y, what's the antiderivative of e to the negative y? Negative e to the negative y. Hey, I got a great idea. Let's find our initial condition. What's our initial condition? 1, 0. So 1 goes in for, 0 goes in for, what's e to the 0? 1 times negative equals 1 minus 3 plus c, or negative 1 is equal to negative 2 plus a constant, or 1 is equal to c. Okay. So, therefore, I have negative e to the negative y is equal to x to the third minus 3x squared plus 1. Pretty sweet, huh? Do you know how many points we've accumulated so far out of the 9? We've accumulated 8. So that's what's nice about these problems. We've accumulated 8 points, and we haven't even done the hardest part. You appreciate that? So let's try to get our 9th point. What do? Get rid of the negative. E to the negative y is equal to negative x to the third plus 3x squared minus 1. How do I get rid of e? Natural log both sides. Get e. Whoop. Negative y is equal to the natural log of negative x cubed plus 3x squared minus 1. Yeah. Okay, so I get rid of the negative by y is equal to the negative natural log of negative x to the third plus 3x squared minus 1. Some people in first hour actually distributed the negative through here. I felt so bad because that's totally illegal. Some people, you can put the negative 1 up top here, but I don't think that really helps you at all. So just leave the negative sign out in front of the natural log. This will give you your final point. So let's accumulate the points really quick again. You had 3 up top there. You get 1 for the separation of variables. And that means that you had your y's with the dy, your x's with the dx's. You have 2 points for the integrals, for the antiderivatives. Okay, so if you came up with both antiderivatives, there's 2 points there. You had 1 for using c. You get another point for using your initial condition of 1, 0. And then your final point comes from your final answer right here. So that's a total of 9. Anybody want to share their score? Okay, so 3. Anybody else? 3. Kyle? 7. Nice work. Katie? 3. Not bad. Remember, 33% of people on this test score a 1. But you're not going to be that 33%. Okay, let's set it up. We got 5 minutes. We'll introduce this problem, and we'll be done. My last instruction. We're taking one last problem. This is not exactly like the homework problem I'm going to assign for tonight, but this is somewhat similar to other problems I've seen on the AP exam. So this is the last one I'm choosing to cover. Again, out of all the content on the AP exam, we've referenced basically everything you would need to know, but there are some tidbits that we're leaving out. There are some things that are not here. So we'll just deal with what we got. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. B of t is the weight of the bird in grams at time t days after it is first weighed. Then d of dB over dt is equal to that. Let y equals bt be the solution to the differential equation above with the initial condition b of 0 equals 20. Can you tell me, the equation I'm given, does that tell me the weight, or does it tell me the rate at which it gains weight? This is a rate equation. That's very important for you to understand. would be like it said dy over dx, okay? The rate equation. The question is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Any idea how we'd figure that out? Yeah, that's all I do. I just plug it in. So we have A. We want to find the rate at 40 and the rate at 70. So I have 1 over 5 times 100 minus 40, and 1 over 5 times 100 minus 70. Okay? What's 100 minus 40? Times 1/5? 12. 12 grams per day. And then 100 minus 70? 30 times 1/5? 6. 6 grams per day. Is it gaining weight quicker at 40 pounds or at 70 pounds? Does that make sense to you that it would be gaining weight faster at 40 grams than at 60 or 70 grams? I said pounds. It's a big bird. Why does it make sense to you? Yeah, I mean, we expect that happens. I mean, babies, proportionally, they grow quicker when they're younger, right? Than when, they're our age. So, all right, so the bird gains weight at a faster rate at 40 pounds. 40, 40 All right. Are we okay with that? So if you recognize it's a rate function, you can see you just plug it in. Okay, again, a lot of times the first question is offering up some easier points. B is a little bit more challenging. You may know what this notation means right here. Second derivative. It means we just find the second derivative. Okay. The rate of the rate. Yep. So it would be like if we're given velocity, we would be finding acceleration. Yep. So that's kind of our comparison here. So we're finding the second derivative. So what I want to do is I want to look at dB. Whoop. Yep. So okay, we pick up here. It says we just left off with the second derivative thing. It says find the second derivative and use the second derivative to explain why this graph cannot be the graph of B. Okay? So this is the wrong graph for B. This is not correct. We want to use our solution to determine why this is not correct. So I have to take the derivative of 1 over 5 times 100 minus B. In other words, I want to find the derivative of 20 minus 1/5 B. So the second derivative, what's the derivative of 20 minus 1/5 B? Negative 1/5. Oh, we're missing something. Hi, Sarah. How we doing? Good? What are we missing? What are we missing? Look at the B. Is it in the place that Y normally is, or where X normally is? B prime. You see, because this is the dependent variable. As you look at here, this is the weight in grams. So this is B, this is T, right? So B is your Y variable. So it'd be like, what if I asked you what the derivative was of 20 minus 1/5 Y? You would say that would be negative 1 over 5 Y prime, right? The difference is they're not using x and y, but b is the y variable. It's dependent. See that? So that's kind of tricky. Why I picked this one out? They do give you a hint, folks. They do give you a hint that you were supposed to kind of think about that, because it says in terms of b. Right now, this is solved in terms of b prime. So I'll write negative 1/5 times. What is b prime? What is b prime? 1/5, 100 minus b. So in other words, our second derivative is equal to negative 1/25 times 100 minus b. That's our second derivative. Okay. Now the question is, why, if this is the second derivative, why is this graph not the graph of the original? Okay, we need to talk more about that negative and what it means. For example, let's look at what are the possible b values that we are plugging in. Look at your graph. What are the possible b values that we would be using? 22, 100. Everybody see that? So suppose that b was somewhere between 20 and 100. What would the result of 100 minus b be? It would always be positive. You can see here that the weight in grams is between 20 and 100. Okay. So therefore, as you look at this example, if you were to plug in 20, you would get a positive value. If you were to plug in something less than 100, you would get a positive value. Everybody agree that this is always positive? Now let's look at Haley's statement, which is this is negative. And a negative times a positive is a negative. So therefore, the second derivative is always concave down. So it's always negative, which means, graphically speaking, that the graph should always be concave down. Is this graph always concave down? No. This graph is concave up for certain values. So therefore, the second derivative is always negative for those values. Whoops, sorry. Thus, the graph of B should be concave down. Part of the graph shown is concave up. So because of that, it can't be the graph. It's a hard problem. It's not easy. I don't know the scoring on that one. I'm sorry, I don't know what people as a nation scored. I don't know the score distribution, but I don't think it was very high. Let's go to a problem that you're more familiar with that you could have a good shot at getting it right. And that is find the particular solution to the differential equation with this initial condition using separation of variables. Here we have it. solve? Oh, it's been negative. Wasn't it? Oh, sorry. What do I do? Cross multiply dB is equal to 1 over 5 times 100 minus b dt. Do I have any t values? Let's put everything, since it has b, over on the left-hand side. So I'd have 5 over 100 minus b dB equal to dt. I've completed my separation of variables. Everybody agree? How do I get rid of the dB and the dt? Integral. Integral of dt is pretty straightforward. What's the antiderivative of 1? C plus c. How do I find the antiderivative of 5 over 100 minus b? Substitution. U is equal to 100 minus b. du is equal to negative dB. I don't have a negative dB. I have a 5 dB, so I multiply by negative 5 du is equal to 5 dB. So I have negative 5 times the integral of 1 over u du. What's the antiderivative of 1 over u? Natural log. So negative 5 natural log. This is where you can insert your absolute value signs of 100 minus b. That's the antiderivative. That's my equation using c. What should I now do? Solve for c. What do I plug in? 0 for t and 20 for b. So I will have negative 5 times the natural log of, what's 100 minus 20? What's the absolute value of 80? Equals 0 plus c. Do I know the c value? Negative 5 natural log of 80. So now I'll rewrite my equation. Negative 5 natural log of the absolute value of 100 minus b is equal to what? Yep, t minus 5 natural log of 80. What variable am I trying to solve for? B. How do I solve? What do I do? Yep, multiply by negative 1/5 or divide by negative 5. Natural log of 100 minus b is equal to, do I divide that all by negative 5 or just part of it by negative 5? All of it, so I get a negative 1/5 t plus natural log of 80. Negative 5's go away. What do I have to get rid of now? So I get rid of the natural log. Base of e. Do base of e, this goes away. I'm left with 100 minus b equal to e to the negative 1 over 5t. I'm not going to write the plus natural log of 80. What will I write instead? Times e to the natural log of 80. What happens with that e to the natural log of 80? Those cancel. So I have 100 minus b equals, the constant is 80, t, negative 1/5t. Now what? Subtract 100, negative b is 80, e, negative 1/5t, minus 100. Yep. So then you would have had a base of E here. It's harder to try to, it's really nice that this e to the natural log of 80 goes away. I mean, they do list the answer. I mean, I did the problem. This is what I came up with. I checked the answer key. This is exactly what they have. So you can leave a negative exponent with a function. So, for example, you would never leave, say, 2 to the negative 3. You'd probably write that as 1 over 8. Like the negative exponent for a function. If you wanted to write it, Haley, as b equals 100 minus 80 over e to the 1/15, you could do that instead. That's absolutely fine. So 5 points for this. They give you, within here, they gave us 1 point for coming up with the second derivative. They gave us 1 point for coming up with this answer and the reasoning. They give you 1 point for coming up with the separation of variables. They give you 1 point for coming up with the antiderivatives. They give you 1 point for coming up with C. They give you 1 point for using the initial condition. And they give you 1 point for coming up with the final answer. That's a hard problem. Why don't I assign an easier problem for your assignment? Number 7. Okay. It's the very last one. It's a small little twist to it, but not that big of a deal. So you'll do problem number 7, which is problem number 5 from the 2008. If you want to, you could look at the scoring tomorrow in class. I can post it for you. But we will not score together in class. Tomorrow is a work day. And that concludes basically all the topics we will do for the AP Reader.